All right, Ninja Nerds, in this video, we're gonna talk about blood typing. All right, so first off, I want you guys to take a second, pause the video, and write down this key because this key is gonna be critical for us being able to go through all these blood typings. Again, knowing that A can give to A and AB, B can give to B and AB can give to AB, and O can give to everyone. And then here's the really important thing with the RH factor, that negative can give to a negative and a positive, but a positive can only give to a positive, not a negative. And we'll explain that. So pause the video, take a second, write that down, because you're gonna need it for the rest of this video. All right, so first off, what do I mean by all these things of A and AB and O and RH and all that stuff? Well, let's come over here. If we look here at this red blood cell, a red blood cell has all these different types of surface markers that lets the immune system know that this is your blood type, right? And any kind of blood type other than what you're supposed to have is foreign. So we got a lot of these blue proteins popping off of the red blood cell membrane. And we're going to denote these accordingly. So there's a specific gene that activates a specific surface marker for A antigen. And there's another gene that can activate a specific surface antigen for B, so that's your B antigen. And then there's another one that can be transcribed and translated to make another antigen, and that is RH antigen. So all of these are different types of antigens to let your immune system know, this is my blood type, anything that could be different from this could possibly be incompatible, and we'll go over that. Next thing, so if you have an A antigen, you're A, that's your blood. If you have a B antigen, you're B blood. If you have an A and a B antigen, you're AB blood. Now here's where it gets crazy. If you have a no A or no B antigen, you're O, okay? So again, real quick, if you have A, you're A blood. If you have B, you're B blood. If you have A and B, you're AB. And if you don't have A and you don't have B, you are O. Last thing, if you have the RH antigen, all that says is that you have RH. So that means that you're positive for the RH antigen, so positive. And if you don't have the RH antigen, that means that you don't have it, so you're negative for it, so you're negative. One more thing. If the person has an A antigen, right, that means that they don't have these specific things in their circulation to protect them called A antibodies. So let's pretend that this person does not have the A antigen. So what would they have in their circulation? They would have anti-A antibodies. Let's pretend that this person did not have B antigen on this red blood cell. So what type of antibodies would they have? They would have anti-B antibodies. And let's say that this person did not have the RH antigen on its cell surface, it would have the RH antibodies. And these antibodies are designed to be able to protect, so this is from our immune system, that protects our blood from getting any type of incompatible blood. And we'll talk about what that means specifically here in a second. All right, so let's go ahead and go through each one of these scenarios then. So what I have over here, I have a whole bunch of different scenarios. I have 3 different dishes. And this first one, in every single one of these dishes, it's coded with anti-A antibodies. This one's coded with anti-B antibodies, and this dish is coded with anti-RH antibodies. So if there's any type of antigen, there will be what's called, so you know if you have these antigens I showed you, those blue antigens? If you have a blue antigen and it interacts with an antibody, this will produce what's called agglutination. Agglutination, which is the clumping. So it'll produce clumping of the red blood cells. So if that means if I have an A antigen and this is covered with A antibodies, it'll produce clumping. So let's say that I actually do. Let's say, look, there's clumping, all this right here, all this clumping, but there's no clumping anywhere else. That means in this one I had to have the A antigen, but in this one I don't have the B antigen, and in this one I don't have the RH antigen. So I'm only going to be A, but I don't have the RH antigen. I'm A negative, okay? So I'm A negative. Let's actually put a nicer color here so we can make it stand out, guys. Let's put another color here. Let's put blue here. So this is A negative, okay? Now, donating. We already said, who can A donate to? A can donate to A, and he can donate to AB. So we already have that down. And then the next thing is, what do we have? He's negative. Well, what did I say a negative can give to? A negative can give to a negative, or it can give to a positive. So this person could donate to A, negative, or positive. And this person could go donate to AB negative or AB positive. Okay? Receive. What type of antibodies does he have in his circulation here? Let's write that up top. That'd be a good thing to write up top. So what kind of antibodies would he have present in his circulation? Because if they don't have the B antigen, they have to have anti-B antibodies, and they'd have to have anti-RH antibodies. So if you give this person any type of blood from B or from RH, they will not accept that. So they can only accept blood from A. So you can only give this person A blood. So they can only receive A blood. And now let's even be more specific. What do they have in their circulation? They have RH antibodies. And if they have RH antibodies, they're going to react with anyone who is positive. And so if they react with anyone who's positive, we cannot give them A positive blood. We can only give them A negative blood. Okay? All right. So that's who could receive from this person, right? Now, let's go on and keep moving forward here. One more thing. Let's also think about another situation. What if this person doesn't even have any antigens whatsoever? No antigens. What is that called whenever they don't have an A antigen, a B antigen, or an RH antigen? Well, we know that the lack of A and B is O, and the lack of RH is negative. So who is our universal donor, in other words? O negative. So O negative can also give this blood. Okay, they can also receive from O negative. Now let's come over here. What if someone clumps in A and they clump in the RH? Well, that means that they're A and positive. So this is A positive blood. So if they're A positive blood, again, let's go back up here. What type of antibodies would this person have? They would have anti-B antibodies. Again, who can A donate to? A can donate to A and AB. The rule says positive can only give to a positive. So he can only give to A positive and AB positive. Next thing, what does this person have in his circulation? B antibodies. So we cannot give this person any type of blood with B antigens on it. So he can only get it from A or O again. So he can get it from A or he can get it from O. But does this person have RH antibodies? No. So it does not matter whether you give them RH positive blood or RH negative blood because they have no antibodies to react with. So therefore you can give this to, they can receive from A negative, O negative, A positive, or O positive. That's so easy, right? All right, so let's come down here and do this one. Let's say now there's clumping in B. So there's an agglutination reaction in B, but no agglutination reaction here in RH. What does that mean? We already know this, right? It's a lot easier now because now we know it's just going to be B, but without the RH, so it's B negative. Go based off that chart again. Who can B give to? He can give to B and AB. But what does the rule say? Negative can give to a negative, and it can also give to a positive. So we're good. He can give to B negative, he can give to AB positive, he can give to B positive, and he can give to AB negative. It's not bad, right? Now, next thing, what kind of antibodies would this person have in their plasma? They would have anti-A antibodies and they would have anti-RH antibodies. So, you cannot give them any type of blood that has A, first off, so they can't get A. So they can't get A or they can't get AB, so they can only get B or O. That's all they can actually receive from. They can only receive really from B and O. O will always be a universal donor, so you can always put O in there, right? Now, let's go back to this thing. What do they have in their plasma? RH antibodies. So they cannot receive blood from anybody who is RH positive. So what does that mean? This can only receive from B negative and O negative. It's easy, right? Now let's come over here and do this next one. What if it clumps within B and it clumps within RH? What does that mean? That means that they are B positive, right? So it's B positive. Who can B give to? He can give to B and AB. What kind of antibodies does this person have within the circulation? Anti-A antibodies. So next thing, if this person is B positive, positive can only give to positive. So they can only donate to someone who's B positive and someone who is AB positive. Who can they receive from? They just cannot receive from anyone who has A. So they can't receive from A or AB. So they can only receive from B and from O. And again, if you look at it, what would this person have? Does he have any RH antibodies? No. So therefore, it wouldn't matter if he's Rh positive or Rh negative. It wouldn't matter. There would be compatibility. So he could receive from B positive, O positive, B negative, and O negative. Right? All right, let's go some more examples over here. If we come over here, and let's say that this person has clumping within the A, clumping within the B, but no clumping in the Rh. That means that they're A, B, negative, right? So this person's AB negative. So if this person is AB negative, right? What does that mean for their antibodies? What would they have within their plasma circulation? They would have anti-Rh antibodies within their plasma, right? So they would have anti-Rh antibodies. Who can they donate to? Well, AB can only, if you look at the chart, AB can only donate to himself. Because AB is the universal recipient. So he's good at receiving from everybody, but doesn't like to donate to anybody but himself. So he can only give to AB. What's the rule though? AB negative. So negatives can give to negatives or positive. So you can give to AB negative and AB positive. So what does he have in his circulation? He has Rh antibodies. But he doesn't have A antibodies and he doesn't have B antibodies. So what does that mean? I can give him A blood, B blood, and AB blood, right? So if you think about it, and again, who can donate to anybody? O. O can always give to anybody he wants. So they could receive from O. Again, who can they receive from? They can receive from A. They can receive from B. They can receive from AB. And they can receive from O. But again, what do they have in their circulation, their plasma circulation? They have Rh antibodies. So if someone decides to give this person positive blood, it would interact and cause agglutination. So they cannot receive from positive blood, only from negative. So it can only receive from A negative, B negative, AB negative, and O negative. Okay, now let's do this next one. Let's say that the person actually has clumping here, here, and here. So this person's AB positive. Now again, who can AB give to? He can only give to himself. Same thing, he can only give to himself. Then we follow the rule. Positive can only give to a positive. So this should just be AB positive here. That's it. Receive. Again, this guy is the universal recipient. So he loves to receive from everyone. So again, he loves to receive from A, B, himself, and O. And again, what does he have in his circulation? He has no Rh antibodies. So this is the perfect recipient. He can receive from anybody. It doesn't matter what blood type. It doesn't matter what's your Rh factor. So he can receive from A positive and negative, B positive and negative, AB positive and negative, and O positive and negative. It's easy, right? All right, now, let's come over here and do this one. Let's say that this person does not have any clumping whatsoever. No clumping whatsoever. Well, I know that if they don't have any A, and they don't have any B, that's O, and they don't have the Rh, it's negative, O negative. Now, if they're O negative, right, they don't have the A antigens, they don't have the B antigens, and they don't have the Rh antigens. So what would they have in their plasma circulation? They would have all of the antibodies in their plasma. They would have A antibodies, they would have B antibodies, and they would have Rh antibodies. So if you think about it, who can they donate to? Well, they can actually donate to anyone because they have no antigens whatsoever. So it doesn't matter what's in that person's, the recipient's plasma circulation. It wouldn't matter because he has no antigens to attack. So he can literally give to everyone. He can give to A, B, AB, and himself. And again, he's negative. Negatives can give to negative or positive. So he can give to positive, negative, positive, negative, positive, negative, positive, negative. But receiving, look, he can't receive from Jack Diddley Squat, right? He can't receive from A, he can't receive from B, and he can't receive any Rh because he has everything to attack that. So literally all he can receive from is himself, right? That's all he can receive from. So all he can receive from is himself. So he's a great donor, but a terrible recipient. And again, why can it only be negative? Because if you try to give them an Rh positive blood, the Rh antibodies will attack it. Come over here. What if this person does not clot in A, doesn't clump in B, but does clump within the Rh? Well, this person is no A, no B, that's O. Clumped in the Rh positive, that's O positive. So if this person is O positive, We already know who he can donate to. He can donate to everyone. He's the universal donor, right? But specific ones, we'll talk about which ones. So A, he can give to A. He can give to B. He can give to AB, and he can give to himself. But positives can only give to positives. They can't give to negatives. So he can only give to A positive, B positive, AB positive, and O positive. What type of antibodies does this person have in his circulation? He has A antibodies and anti-B antibodies. So if you try to give this person A blood, B blood, AB blood, it would actually cause clumping. So that's not good. We do not want that. So again, he can only receive from O in general. He can only receive from himself. So he can only receive from O. But does this person have an Rh antibody? No. So because he doesn't have an Rh antibody, it does not matter what kind of blood you give him, whether you give him positive or negative, they don't have antibodies to attack it. So this person can receive from O positive or O negative. That's it. Now, before we finish up, I want to talk about one of the most dangerous mismatched transfusions, but it's actually endogenous. It's actually within the person's body. So when a woman is pregnant, this usually isn't a problem in the first birth, and sometimes not even in the second birth. It might actually be, the chances increase every birth. Where a mother, let's say the mother, is Rh negative, and the baby is Rh positive. So again, it's not a problem within the first birth and sometimes not even in the second birth, but the chances increases with every birth. If the baby is Rh positive, that means that it has to have a Rh antigen on the membrane. So look, here's this Rh antigen in the baby. So this is your placenta, fallopian tubes, right? And here's your baby, and it's got the Rh antigen right there. So the Rh antigen is present there. In the first birth, whenever the placenta breaks away from the actual, from the uterus, some of the blood from the fetus can actually leak into this actual mother's blood. And whenever the mother receives this Rh positive blood, let's say that she's Rh negative, so she doesn't have any antibodies. So look, this actual baby's red blood cell gets leaked over into the mother's circulation in the first birth. So the first birth, it was okay, right? Because the mom doesn't have Rh antibodies unless she's actually had some type of mismatched transfusion. If these red blood cells get leaked in here, now look, it's got the Rh antigen right here. If it's got the Rh antigen, the mom's immune system will produce antibodies against those Rh antigens. But in the second birth, so now in the second birth, this person, let's say that she has another baby who's Rh positive by terrible chance. Now she has the anti-Rh antibodies. So in the first birth, her immune system, so let's say here's her immune system, the immune system will produce these antibodies in response to this actual mismatched transfusion from the baby. But now, watch what happens here. In the second birth, if the mother, again, is having a baby who's Rh positive, these antibodies, they can cross the placenta. You know, they're IgG antibodies, and IgG antibodies or IgM antibodies can actually, well, specifically IgG antibodies can cross through the placenta. And look what happens over here. It comes over and it attacks. It attacks this baby's red blood cells. And if these antibodies attack this baby's red blood cells and undergo agglutination and hemolysis, then this baby is going to have hemolytic anemia. And this is a very, very terrible condition because it actually destroys a ton of the baby's red blood cells, increases bilirubin levels to the maximum, and actually can cause kernicterus and mental retardation, a lot of problems. This baby will develop a condition which is called hemolytic disease of a newborn. Or sometimes they call it erythroblastosis fetalis. Okay, and again, what does that cause? It's usually more common within the second or third or fourth birth, where the baby is Rh positive and the mother is Rh negative, and her antibodies, her anti-Rh antibodies, attack the baby's red blood cells by crossing the placenta, cause hemolytic damage, kernicterus, mental retardation. It's a very, very dangerous condition. So now what they do now, when they recognize that and they know that, they give a drug. They give an anti-Rh antibody drug. So they actually give a drug to block this. Look at this. So now I can give a drug to block this. What are these little purple proteins here called? This purple protein is called ROGAM. Not Rogaine, ROGAM. Okay? Rogaine is for hair growth. You don't want that. We want ROGAM right here. So ROGAM is an anti-RH antibody. And look what it does. It actually binds here to these anti-RH antibodies and prevents them from actually attacking the baby's red blood cells. And then what will happen then? There won't be any destruction or damage to the baby's red blood cells. So again, that covers every much that we're going to need to know here for the actual ABO blood typing and erythroblastosis vitalis. All right, Ninja Nerds.